Let's find the critical points of the function f of x is equal to x times the square root of x minus a. And here a is a constant. It could be any real number. The definition of a critical point is where the derivative is equal to 0. So step 1 is to take the derivative of the function, and I'm going to rewrite it slightly as x times x minus a to the 1/2 power. And I see that we have a product of two functions, and what this means is I have to use the product rule when taking the derivative with respect to x. So to start, the derivative of the first thing, x, is just 1, and then we multiply that by, okay, now we just copy down the second thing, which is x minus a to the 1/2. The product rule continues by saying we add on. All right, now we leave the first alone, and then we multiply by the derivative of the second thing. So when we differentiate just this expression, we have a 1/2 that we bring down front. So I'll start there. That's 1/2 times, now we copy down the inside, which is x minus a, and then we subtract 1 from the exponent. So I like to think of that as subtracting 2 halves to keep the denominators the same. And so we get negative 1/2. And finally, by the chain rule, you have to multiply by the derivative of the inside. Well, the derivative of x is 1. The derivative of a constant is 0. The chain rule, you could write it, is multiplying by 1, but it doesn't change the value of the expression. We could have just left this off. But anyways, here it is. This is the derivative of this function. To set it equal to 0, it might be a good idea to maybe rewrite this a little bit. So I'm going to maybe make this exponent so it's positive instead of negative, and see how that changes things. This very first part, I don't need this 1, and I'm just going to write down x minus a to the 1/2 power. So the first is just x minus a to the 1/2. And then we're going to add on, okay, a negative exponent to this entire part puts x minus a in the denominator with a positive 1/2 exponent. So we have a fraction in the denominator. Well, the 2 is already there from this 1/2, but I'll write x minus a to the positive 1/2 power in the denominator. And in the numerator, we have x, a 1, and a 1, so that's really just x. So this thing. And specifically, we want to set this equal to 0 to solve for x. All right, let's see. I think maybe I'll get a common denominator, which essentially means I'm going to multiply this by this denominator in the top and the bottom. So that is, I'm going to multiply by 2 times x minus a to the 1/2, and then by 2 times x minus a to the 1/2. In doing this, we now have a common denominator of 2 times x minus a to the 1/2. So I'm going to write this as one fraction, whose denominator is 2 times x minus a to the 1/2 power. Now, my numerator, over here, we're not changing this fraction, so we'll have a plus x at the very end. And over here, well, we'll have a 2, so I'll put 2. But when you multiply something to the 1/2 times that very same thing to the 1/2 power, you would add these two exponents. A half plus a half is 1, so I'll put that as x minus a to the first. And this should be equal to 0. When does that happen? Well, I don't really need this 1. In fact, I could distribute this 2 into the parentheses, and we have 2x minus 2a plus x all over 2 times x minus a to the 1/2 is equal to 0. And I can simplify the numerator a little bit. We have 2x plus x is 3x, and then we have this minus 2a, which doesn't combine with anything. So that's 3x minus 2a all over 2 times x minus a to the positive 1/2 is equal to 0. I think from here it'll be easy to solve this equation. A fraction is equal to 0 if the numerator is equal to 0. So what I'm going to do is ignore this denominator, and on the next slide, I'm just going to write 3x minus 2a equals 0. Again, that's because a fraction equals 0 if the numerator is 0. So like I said, 3x minus 2a is 0. I'll add 2a to both sides. I will divide both sides by 3. And I get x is equal to 2a over 3. All right, so this is a critical value of the function. But wait a minute. There's all these options they have to choose from to get the correct answer. And it like kind of separates it out between like, well, what if a is a negative number, or what if it's, a positive number? Is this still going to be a critical point of the function? So, a is not positive or negative. We assumed a could be any real number, but maybe we have to be a little bit careful. Maybe if a is negative, that's an issue. Maybe if a is positive, that's an issue as well. Let's go back to the original function, which was f of x is equal to x times the square root of x minus a. So I'm going to take this expression and put it into all the x's and see what this function looks like. So what I'm doing is I'm actually putting this into the function. That means it goes in place of the first x. And then under the square root, it goes in place of the next one. And there could be an issue here. We have something underneath a square root. Maybe I could try to express this as one fraction. So to do that, I need a common denominator. I'm going to multiply this a by 3 over 3. And what that will do for us is we'll get a common denominator 3, and we're going to have 2a minus 3a, which is going to be negative a. So what all of this is saying is, if you take this critical point, 2a over 3, and you plug it into the function itself, you get this. Now, you cannot take the square root of a negative number. So if a is positive, then negative a is negative. In fact, the entire thing under the square root would be a negative number if a is positive. So I'm just going to say that, this is bad. There is no critical point if a is positive, because when you plug it into the original function, it puts a negative number under the square root. So the function isn't even defined at this point. But what if a is, what if it's less than 0? So what if this happens? So in this case, the value under the square root will be a negative times a negative, which is a positive, and you can take the square root of a positive number. So in this case, I would say that this is good. And then the only thing I have not considered is, well, what if a actually equals 0 itself? If you look at the function in this case, if you substitute a is equal to 0, we're going to have x times the square root of x as our function. And this is the same thing as f of x is equal to x to the, well, the exponents are going to be a 1 and a half. And if you add those, you get x to the 3 halves. And the critical value, if a is equal to 0, is x is equal to 0, which is an endpoint of this function. So this is not a critical value either. So in this case, if it's negative, that's good. If it's positive, it's bad. But if we actually include 0, we don't get a critical value either. So this is the case that doesn't work. So up here, I want to choose the option that best reflects this. So that is, if a is less than 0, there is a critical point occurring at this x value, and if a is positive or if it's equal to 0, then there isn't one. So I want to go with this option here. And that is it for this problem.